Hi everybody, let's do a quick recap of this week's problem set. This is the most popular solution to problem 2. A couple of other nice things that I saw people do were to realize that divisibility by 2 and 3 means that you're divisible by 6. So they made it one step simpler by doing this. I also saw a lot of people define their own methods, which makes it very readable and nice. It looks like this when you do it. You can see that in some ways having the named methods here is divisible by 3 makes it read a little bit nicer. As far as what those methods look like, I saw some people have an if-else statement like this, but I want you to realize that you could actually just return the result of that Boolean expression. Because here we're saying, is it true that the remainder when you divide by 2 is 0? If it is true, we return true. If it's false, we return false. So really, a shorter way of saying the same thing would be return whether or not it's true that dividing by 2 gives you remainder 0. So that would be sort of a one-line version. I also want to point out that you could have a single method that combines together these two. Here we've got a magic number 2 and a magic number 3. Magic because they're sort of constants. What if we had a method called is divisible, or let's call it divides by, and so here we'd test if our number was divisible by whatever this value was. And so now this works for both. We could say if I is divisible by 2 and I is divisible by 3. So in a lot of ways, it's nice if you can have a single method that's sort of multi-purpose. I don't know if that's my favorite thing to name it, but anyway, you see the idea, I hope. For the next problem, I saw a lot of people do something like this. So we have the user choose a number, we generate the random numbers, and then people had an if-else chain that tested for all of the possible ways that your number could be related to the random numbers. So here, like the user number is between 1 and 2, in which case you're a winner. Here it's between 2 and 1, in which case you're a winner. Here is where it's the smallest number, and then random 1, and then random 2, and so on. So all these possibilities. This is not wrong. Let me make 2 comments. So first, the use of spacing here, all of this feels very compressed. I think if we spaced it out a little bit, it would read a little bit more nicely. Like this is easier to look at than this. And that kind of stuff matters for code reading. So that's one point I'm going to make. Ah, yeah, look at that. So I hit Control-Alt-L, and it auto-formatted to make the spacing look nicer. Okay, so my second point is, again, there's nothing wrong with doing it this way, but you could think a little bit about how you might be able to make this shorter and nicer. So here's one approach to doing that. You could, for example, use math.min and math.max to find which of the 2 random numbers is smallest, which of the 2 random numbers is largest. Now that you know which is which, you can ask if the user number is between the smallest and the largest in a single if statement and display winner. Otherwise, you can ask if user number is smaller than min, then start with that one. If it's larger than max, then end with the user number. So we've reduced the number of if statements by a couple of them. A couple of people knew that there are built-in methods that will sort values in an array, so they actually made a 3-element array out of these numbers and then sorted it and used that. That's a great solution. A couple of people know about something called the ternary operator, which is a very short way of doing an if-else statement, and they used that, and that was nice. But I would say this is, without using these kind of special purpose things that we haven't talked about yet, this is a solution that I think you should be proud of if you came up with. And if you didn't, of course, you can next time, because that's how we learn to program, is we do it wrong 1,000 times, and then eventually we do it right. Generally, people did a good job with 2a, but I saw 2 kinds of mistakes. I saw people just blindly putting a bang in front of whatever Boolean expression they wanted to negate. If it's something like n larger than 0, there's nothing wrong exactly with writing this, but I think it's confusing. Like, what does it mean if a number is not larger than 0? It must mean that it is less than or equal to 0. So instead of doing this, please do something like this for numerical cases. For this one, I saw a lot of people have a single equals sign, which is assignment. It does not actually test if things are equal. And same thing here. If you're trying to test if things are not equal, generally you don't put the not symbol in front. Generally you would put it here as not equal. So this is now a good solution to 2a. For 2b, this is a great solution. Take the two things that are common and put them outside of the if-else. I saw a couple of people put them afterwards, but the reason that that doesn't work is because the if-else statement changes the value of x. But in the original code, method 2 was running with an input of x on the line before x changes. So in order to keep method 2 running with the correct version, of x, you've got to put these two before the if-else. And then for part C, this is a totally great solution. I saw a couple of people have a separate variable to represent this, and they would just add 10 every single time in the loop. Either approach works. It would be good for you to understand both, however. For problem 3, this is a perfectly good solution as well. I saw a lot of people use math.pow. I would say don't use math.pow if you're raising an integer to a relatively small integer power. If you're just cubing something, it's way, way faster to just multiply than to use math.pow, because math.pow uses an iterative, well, we'll talk more about how math.pow works later, but it's much slower. For part A, the correct solution should be 4 lines, each counting up from 0 to higher and higher values. The way to think about that is think about this for loop in green as its own single statement. Think about what this entire chunk of 3 lines of code is going to do. It's going to display values of j, and the values of j count upwards starting at 0. And it's going to stop as soon as it's 1 smaller than I, because as soon as it equals I, this condition will be true and it will exit. So, for example, if I was equal to 10, then these 3 lines of code would print 0, 1, 2, 3, 4, up to 9. If I was 7, then this code would print from 0 up to 6. So if you can think about those 3 lines of code as performing a single operation, count from 0 up to 1 less than I, now you can think about what's going to happen when we're in this outer loop. I starts at 0, so that means we're going to count from 0 up to 1 less than 0. And so this doesn't actually run at all the first time through the loop when I equals 0. When I equals 1, the second time through the outer loop, we're going to count from 0 up to 1 less than 1, which is 0. And so that's what displays this first 0, because j starts at 0 and ends at 0. Then the next loop, when I equals 2, we're going to count from 0 up to 1 less than 2 here. In the next outer loop, when I is 3, we're going to count up from 0 until we get to 1 less than 3, and so on. So that's the way to think about it. Think about the inner loop on its own as a single statement that's doing something, and then think about how that fits in the outer loop. Part C says, modify the program so that the output for each line counts down to 0 instead of up from 0. So this is the desired output. I'd count down until I get to 0 on each line. So let's modify it. Here the I value is saying what's the largest number on each line. So that part we don't want to change at all. We only want to change what happens within each line, which is about the green for loop here. So rather than starting at 0 and counting up, we'd want to start at I, or maybe I minus 1. I didn't really specify. We want to subtract 1 every time, and we want to keep going as long as j is greater than or equal to 0. So here we're saying start with the I value and go down until we hit 0. That's it. Part D asks you to modify the code again so that after you get to 0 on a particular line, you display zeros until you get to the end of the line. So the first time through the loop, it looks like I need to add 1, 2, 3, 4 zeros. And then I need to add 3 zeros, and then 2 zeros, and then 1 0. So how can we modify the code to do that? If I was going to write this in pseudocode, I would say display some number of zeros. So I want to have the code that counts down until we get to 0. And then after we get to 0, I want to have one or more lines that will display several zeros. How many zeros? Well, so an easy way to do it would be to create your own variable to represent that. So let's call it number of zeros. And we know it should start at 4 because by observation, we saw that the first time through the loop, we need 4 zeros. So let's display num zeros, zeros. And then after we've done that, let's subtract 1 from num zeros. So that way, each time through, each time I go to the next line, I'm going to subtract 1 from how many zeros I'm going to display. So how do I display a certain number of zeros? Well, that's easy. We just have a for loop that loops that many times. So I could reuse j if I wanted to, or I could have a different loop counter. So I'll say k goes from k is 0 up to num zeros, because this is the typical pattern for looping a particular number of times. So if this is 10, this pattern would loop 10 times. If this is 5, this pattern would loop 5 times. And then I just want to say system.out.println 0. And that does it. So again, I want to emphasize the process that we used to get here. We started off by thinking about what does the program already do? Then we thought about what do we want to add? And we thought about it in a structured way. The first line we want 4, then 3, then 2. So I added a line of pseudocode that tried to express what I wanted. I want to display a certain number of zeros every loop, but that number is getting smaller and smaller. And so then I started trying to translate my pseudocode idea into actual code. If you didn't want to use an additional variable, num0 equals 4, you could do this. You could say 4 minus I. Let's think about, and then remove this. Let's think about why that would be the same. The first time through the loop, I is 0. So 4 minus I is just going to give us 4, which is what the number of zeros we want to add. Then as I goes up by 1 every time, 4 minus I goes down by 1 every time, which is what we wanted to happen to the number of zeros. So when I was 0, we had 4 of them. Then the next time through the loop, I is 1, and so we'll have 4 minus 1 is 3 of them. And then the next time through the loop, I is 2, so we'd have 4 minus 2 is 2 of them. Problem 5 has very similar reasoning. So we have the user type a number. We save it into a variable, which I'm calling max stars, because it represents either the maximum number of stars we want in the top row or the total number of rows. Oh, by the way, the output's supposed to look like this. Here, this sort of triangle of stars. So if they were to type 6, max stars would be 6, which is both the total number of stars in the top row or the number of rows. So the outer loop, my loop counter is called num stars because I want that loop counter to represent how many stars I'm going to display in the current row. So I'm going to start off displaying the maximum number of stars. I'm going to subtract 1 from how many stars I display with every loop, and I'm going to keep going until I get to 0. This for loop is just looping j from 0 up to num stars. So remember, this is the pattern for display a particular number of stars. So the first time through, it's going to display max stars. Then the next time through, it will display 1 less than that, and so on. And then, just like in the last problem, we have a print line statement, which moves us to the next line. For problem 6, I saw a lot of people have solutions that involved a pattern like the following. You'd have a Boolean variable that keeps track of whether you're finished, and an if statement that tests to see whether or not you should set your flag to true, and then you stop when you're done. This is called a Boolean flag, and there's nothing wrong with this, but in the AP test, they're definitely going to test to see if you can have more complex conditions in your loop expression itself rather than use a Boolean flag like this. So for this problem, there's a couple things we could do. Let's delete our flag. We want to keep going as long as it's not true that all 3 of them are equal to 1. So let's start off this way. We'll say as long as R1 equals 1 and R2 equals 1 and R3 equals 1. So we want to keep looping as long as this is not true. So one easy thing to do is you could have not and then put this entire thing in parentheses. So we're going to evaluate this entire expression first and then have not. That would be fine. This is a little bit hard to read. I saw some people define their own method for this end condition, which I thought was nice. It looks like this. We've named the method all1, and it just tests to see if all of them are equal to 1. And we're going to say do the following while it's not true that they are all 1. So that's, I think, a nice way of organizing this idea. A couple of people realized that if all three of them equal 1, then their sum has to equal 3. And there is no other way to get a sum of 3 because it's not possible that you could roll a 0 on your die. So they knew that as long as this sum doesn't equal 3, we should keep going because equaling 3 is the only way to ensure that they were all 1. So that was another kind of clever short way of setting the condition. A couple of people thought more logically about it. What would it mean if it's not true that they're all equal to 1? Well, it would mean that either R1 doesn't equal 1, or R2 doesn't equal 1, or R3 doesn't equal 1. So this is a logically equivalent expression to this up here. This is saying it's not true that all of them together, that all of them individually are 1. This is saying either this one isn't 1, or this one isn't 1, or this one isn't 1. And those two are going to result in the same output. Along those same lines, in problem 7, we could say keep going as long as it's not true that answer is between 10 and 15. Or, equivalently, we could say keep going as long as answer is less than 10 or bigger than 15, because that's the same thing. The only way of not being between 10 and 15 is either if you're smaller than 10 or if you're larger than 15. So again, there's usually multiple ways of expressing these conditions. Same thing again, but now with 3 conditions. We still have the condition that it has to be within a range between 10 and 20, but now it also has to be odd. And so as long as it's not in the correct range and odd, we want to keep going. So this is one way that you could express the condition, or we could list separately all of the different ways it could fail to satisfy our conditions. We could say that either answer is less than 10 or answer is larger than 20. Oh, sorry, it should be equal. Or when you divide it by 2, the remainder is not equal to 1. The while loop here, we can initialize the counter to 10, and we subtract it in the loop, and we keep going as long as it is larger than 2. I hope that helped.